Good evening all. So this is the AXI part 2. We are considering to be continue with the series of AXI. Under that we can have the AHB as well as the HP also in later series. So today we see the AHB code generation and verification as we are referring to the this GitHub link. I hope you gone through the earlier video. I tell that AXI details there and how we can generate the code and verify that. So for the just wrap up, we are referring to this link. It is based on the bash GCC. We are using the simulator like Verilog, and we are trying to our best to work on the VCS and the Cygwin platform. So there are three generations of code and verification provided by this link. So we already covered the AXI. Now AHB and APB is remain. So today we are covering the AHB. Later we see the APB. Okay. So for the more detail of what is that AXI, AHB and APB, you can refer the others links or videos. We are much focused on the code generation and the verification for the time being. Later we will see based on the what we can do. Okay. So the basic difference with the AXI and the AHB. This is AXI is a full duplex and this is a half duplex. So in general the AHB is a more light version of the AXI, and it is very easy to implement, whereas the AXI is a complex one. So how before going into the code generation, I just look up the what we are doing actually. AHB sits on this AMBA AHB bus system. This is a light version of anything like controllers or something like, but it is useful, we can say, if you are having the some moderate kind of things. So AHB can handle. So also the signaling of the AHB for the master interface, this is look like this. You can pause and you can read this signals. Similarly, this is an overview of the slave interface signaling, and there will be the arbiter which take the request from the masters and the grant the request for the interconnection or transactions. So the signaling names like this will be there. So in general, how it look like, left hand side maybe the more than one masters, also the right hand side maybe the more than two slaves are there. So there will be this kind of signaling names will be there. So all the controls lie within this arbiter and the masters. Okay. So back to the our so if we have a complex SOC, then there will be the AXI as well as the AHB also. So to transact between these two, if you see this AXI to AHB and the AHB to AXI bridge will be there. So again for the APB, there will be the also bridge from the AHB to APB like that. So later on that APB have some low bandwidth peripherals will be there. Okay. So in more details structure will be look like this. It is just representation, otherwise what we see, it is a similar diagram. This side is a AHB master 01, this to be like two masters, two slaves, like that. So when we generate the simulation tops, so we can have the two masters, three slaves, or two masters, two slaves with the like memory, like slave will be the memory. So for the top generation, it will be the we can place the size of memory. If there is two memories, then it will be 1K first and 2K second, like that. The addressing size or depth will be like this one. Okay. So as we seen that the every transaction has the ready and the valid signals like that in this code. It means is a two-way valid ready handshake will be there. So on the GitHub side, the detail generation and the verification process is given, but for the readiness I put it here. This is a same thing is there. We have to go inside the AMBA AHB. We have to make first. If you repeatedly using the make, then you have to first go through the make cleanup or cleanup all, like that. So after that it will generate the some gen AMBA AHB executable. -H will be used for the what are the options we can have. So next step will be the we have to mention the how many masters you required, how many slave you required, and the name of the file. So these are the basic steps, and also verification is a similar things are there. But while I am following these steps, I found some break in this process, or we can say that it is not one go okay working steps are there. So I make my own steps for the process. So these steps can be verified on the current download from the GitHub clones, and I can try and I can show you how we can go through this. So first step will be we have to go to this GitHub extracted locations, and inside that there is this 4 folders will be there. So we have to go inside the AHB folder and we have to make. So we try on the window platform first. So we can refer one by one steps. Okay. So I am already in that folder, so I have to for visualize what are there inside that folders. So these are the details of the contents. So I just have to make like that. It will process the sources of the C code using the GCC compiler, and it will create a one executable file. So again we can have check that file. This is the file that recently it is created. So I just check the what are the options are there. These are the options as seen there. Okay. So for that we have to make one design folder inside the verification. Okay. So I can make that one by one. I can copy and the paste there. Then we have to create a bridge. So just copy paste the commands. then go inside the verification directory. Then we have to create a top which is going to be at inside the design, okay, folder. So we have to go inside the sim IV, okay. Then you just make, if everything is okay, then no need for this command. This command means vim. We don't need this command actually. So from that we can see it is generating and verifying the code. So we can check the also the GTK wave file. I hope this time it will open. So in that there are lots of details are there. There's like master 0, master 1, 2 slaves are there. So I just check whether that waveform has something to visualize or not. The Linux machine. So up to this commands, it is the same thing for the VCS, okay, but in make file we have to make some changes there. So what changes I make in make file, you can see. Okay, one. Okay, this is for AHB. Okay, you can make a copy of it to CP, make one to make. Okay. So now we can have make command. This is working for the VCS as well. Now the DVD opens, as we've seen there. So we can have control A, control 4, then waveform window will open. Just hit F5. So in this way we can have compile and simulate. So basically there are lots of waveforms are there, signaling waveforms, but we don't know what actually happened right now, because we are just checking the code validity, whether it is working or not. So and how we can get that compile and simulate. So later on we will see what exactly location, what it is writing and what we are reading. We will see later on that. So also we get the same messages in the console what we seen in the window machines. So also we can have the schematic also there, like that. Anyway, I hope you got the process. So thank you for all watching this, and please subscribe and please support me. We'll see much more on that. Thank you.